Okay, in this video I'm going to be talking about a histogram and how we might generate one in Elixir's Livebook using VegaLite. This could be multiple videos. I don't know how it will go. We'll see. I've even already had a video, didn't like it and deleted it, so I practiced a teeny bit this initial part already once. Okay, so what is a histogram? Well, I usually start in Wikipedia. I do like and trust actually there as a starting place for information. And a histogram, ultimately, I'm not going to read this. You can read it on your own and go there, of course. A histogram is a visualization of your data's distribution. All right? And so what does that mean, right? Well, the distribution, you might want to look at your data within some set of ranges, or you might want some in the total range. You might want to set some number of ranges and then see how much data is within those ranges. Those ranges are technically called bins. All right. So when you create a histogram, you usually start and define either the number of bins you want or the ranges of your bins. All right, which will roughly get you to the same place. But you can think of it both ways. Once you have your bins, right, then you count the frequency of data within each of those bins, and then you simply represent it visually, usually by a bar chart. And the height of the bar tends to be, or is the frequency. And then from that, you can see the distribution of your data. All right, so that's a histogram. Nice and simple. It's essentially a statistical summary of your data, right? It's often used in analytics when you have time series data and you want to get a rough idea of what that time series data looks like. Time series data, of course, as it hopefully makes you think, time series data is quite voluminous, right? Because if, let's say, you're capturing some amount of data every second, that's a non-trivial amount of information, especially depending on what your data that you're capturing is, right? So for 1 minute, if you're capturing every second, that's obviously 60 seconds. And if you're capturing, I don't know, 10 bytes, right? It's not a trivial amount of data ultimately once you start running that for days and weeks, right? So what often happens in analytics is data on the edge, right? So this is where it's called on the edge, being on the client edge side, edge analytics. You take your time series data and you aggregate it, and histograms are a common aggregation or statistical summarization. All right, so that's a histogram. It's a visualization of the distribution of your data. So how do we start? Well, when we start, as we just talked about, you need to figure out the count, essentially, of your data within your bins. So you need to define your bins, that's lovely, and then you need to count it up. So we're going to start writing some code, and first we'll we need to get some data. So let's go start to generate some data, all right? So in our histo module script, we need gen data, and we want some number of nums, how about NONS, number of nums. That doesn't look very helpful. So number of numbers, right? And then our range of our data, because we're going to just do numerical data at the moment, but you can use any data ultimately with a histogram. There's no reason why not. So we need a start range of our data, and we need an ending range of our data to generate, right? Remember, we're generating data. So lovely. So how might we do that? Well, we essentially probably want to loop some number of times and generate a random number that's within our range, right? Probably, assuming you know Elixir, 2 obvious loops ought to jump into your head. There, of course, is some enum function, right? Or a list comprehension. And it seems like a list comprehension is quite reasonable here. So we want to for, and if I remember my syntax right, we want to for some number of times, right? So what do we want? We want to do this however many num of nums we want, do, right? And since we're never actually going to use n, we can just ignore that, right? And let's just output, for the moment, some value to make sure we even have our code right? Let's test it right away. So now we're going to call this histo gen data. Let's say we want 10 numbers with from 0 to 15. All right. We want to see this, so we'll do an IO inspect, and perfect. We'll save this. We'll go over to our let's Elixir this. We have some warnings because we never use some stuff, but we have a whole bunch of 4s, and presumably that is 10 4s. I'm not even going to count it because I think we're pretty clear. Okay, so how do we make a random number? Well, if you've been around Elixir long enough, you'll know that Elixir essentially does not have a built-in, so but Elixir can call Erlang's functions, so that's what we should use. So Erlang, you write documentation, and do I have it in my history? So I don't know. Erlang random number docs. Let's just try to, so random. Let's jump into random. Right, first link we'll look. And since I've done this before, and lots of us have, I tended to remember that random is not the module they want you to use anymore. It looks like there's an improved rand module, so let's just go there. So perfect. All right, a whole bunch of crap in here, right? Lots and lots of stuff. So we know we just want to get some random numbers. If you know a little bit about it, you want a normal distribution, a uniform distribution, or there are other types of distributions. We just want to get a number out, right? And so I'm going to skip a variety of these because I roughly know what we're looking for. So what is normal? Though I don't have it memorized. Returns a standard normal float, right? And so perfect. So maybe, right? We want normal. I never really know. For some reason, normal feels like the one I want, but I know I've been bitten by this. The other one I want to think of is uniform, all right? Returns a specified number, so this feels better. Right? Returns a specified integer. So good, we wanted an integer. That's helpful, right? We didn't want floating point numbers. And it gives it from 1 to n. And it is n is greater than or equal to, so the range is 1 to n inclusive of n. We tend to not think that way, right? Ironically, in programming, usually, we tend to think to zeros and -1 indexes and all that. So I'm going to basically, whatever random number I get out, I'm going to subtract 1, right? So I'm going to ask for this range. What am I going to do? I'm obviously not, I haven't thought enough ahead. I'm going to get myself a normal number from 1, so this doesn't give me within a range, duh. So I'll have to either build my range. Let's see if there's one that gives me a range. Uniform as returns. No, I'm not. I don't see one that gives me a range. I might search for the word range. All right, let's see if there's a range. Uniform integer ranges is skewed distribution, something, whatever. For a general range with n equal 1. Uniform has a range, that's not what we want. Uniform real, also not what we want. Uniform gives us a range of 1 to n, finally, fine. Uniform S is a float, also not what we want. Also not what we want. So it doesn't look like there is a range that I see here. And since I'm no expert, looks like we will, I could keep searching for range, but this is annoying as hell. All right, so let's get ourselves a number. Rand, uniform, what? So if we go back up in our uniform, we're going to get a number from 1 to n, right? So we need to know what our range is, and our range is range end minus range start, right? Let's just run this. Make sure we get something lovely. Obviously, since I've asked for 0 to 15, I happen to get numbers that are nice. We do see a 15 in this output, but we weren't expecting that, or we were expecting our range. So let's subtract 1, right? Run this again. And perfect, now we have zeros. We have an example of 0. I'll run it again. Right. Do we have any duplicates? Because otherwise doing binning and stuff will be pointless and useless. Well, we have 1, 2, right? So perhaps we'll want to generate a few more pieces of numbers. So let's get 20 of these. So now, do we have some duplicates? I see a 7, I see 3 7s, that's lovely. I see 2 6 really quick. Okay, we got a bunch of numbers and we have duplicates. Our range is, because it's at 0, this isn't going to work in the future, but for the moment I'll ignore that. In all likelihood, we'll just have to take this number and multiply by range minus, right, again, to move it within, we'll have to probably, multiply it by add start. Oh, that's pretty easy. Let's just do that. Add range start, right? So if we add range start, it's 0 in this case. We're not going to change anything. So this should shift it up into our range, our desired range. Okay, so lovely. In Elixir, where can we get some of our own frequencies or our own distribution? And I already cheated in a sense, right? I gave you the magic word. In enum, there is a frequency function. So let's go look at frequencies, right? And what does that do? Let's look at it. Let's run it. We already have our list, so let's just run frequencies through. And of course, we want to see what it looks like. So we now have our list, and then we have our frequencies. Left, our keys are our numbers, and the values are the counts. All right. So we have 113. If we look through quickly, I see a 13. I don't see multiples. Let's take 9, 1, 9, 2 9s. Is it 2 9s? Yes, it's 2 9s. All right, there seem to be 3 2s. Let's verify that. 1 2, 2 2s, and the last one is 3 2s. Are there any other 3s? There's 7. So let's do one more check. Not that we're verifying, or we are, but whatever. 3 7s. Excellent. So this is done. In a sense, we've already binned sort of our code, our data. What have we binned on? We've binned on integers, right? We care just about integers, not a range of integers at the moment. So this already is a binning, okay? So I'm going to pause there, and actually, I think I'll stop right there and come back in a second video.